In today's session, I will review our product line, technical data, main features, product performances, and our added value. Our high-pressure product line offers a variety of fittings such as straight, elbow, cross, T, and reduced connections. In our needle valve line, you will find manual and pneumatic actuators. We also offer cone and threaded nipples and tubes with different size and lengths. Pre-assembly tools such as coning and threading tools. Any installation of HHP elements with cone and thread, CNT, end connection, either to fitting, adapter, or a valve, must be conducted by the following steps. 1. Lubricate all male threads with any anti-seize lubricant. 2. Apply the same lubricant to the cone end of the tubing. 3. Thread the collar counterclockwise, left-hand thread, to the tube, up to 1 to 2 full thread space from the cone end of the tube. 4. Insert the tube with the collar into the fitting body. 5. Before applying the final torque, pay attention that the tube is on full contact with the female cone on the fitting body. A full metal face-to-face contact should be achieved. 6. Thread the gland into the fitting body until finger tight. 7. Hold the fitting body steady and tighten the gland. Coning tubing end. To get a proper sealing, you must use the HHP coning tool that provides approximately a 57° to 59° cone at the end of the tube by completing the following steps. 1. Cut the tube with a Hamlet tube cutter and make sure to clean it properly with a Hamlet deburring tool. 2. Place the coning tool on a suitable vise and secure the body so you will have access to the collect nut and knurled cap. 3. Rotate the knurled cap as far as possible towards the coning tool body. 4. Take the knurled cap back away from the coning body by rotating it counterclockwise for 4.5 number of complete rotations. 5. Insert the cut tube into the collet. 6. Tighten the collet nut on the tube in order to secure its position. 7. Apply a small amount of oil, cutting fluid, that is provided by HHP into the cutter and the coning body. 8. Reassemble the cutter and knurled cap back on the body until the cutter touches the tubing end. 9. Rotate the handle of the cutting tool clockwise rapidly with one hand while simultaneously slowly rotating the knurled cap clockwise with your other hand. Do not force the cutter against the tubing because it will bend. In order to perform the cone completely, please rotate the knurled cap. 10. After finishing coning the tube, remove the tube from the collet by loosening the collet nut. Make sure to clean the cutting fluid and metal chips that remain in the body for the next assembly after removing the knurled cap and the cutter. Threading tubing ends. In order to get a left-hand thread onto the end of the tube for a proper connection, you must use HHP threading tool and operate by the following steps. 1. Remove the knurled cap and the cutter from the coning tool, as it will be used as a holder for the tube threading operation. 2. After the tube is secured in place, please place an amount of oil, cutting fluid, on the end of the tube. 3. Place the threading tool onto the tubing while guide bussing side is first. 4. Start to rotate the threading tool counterclockwise by using your hand on the tool, and once momentum is gained, start to do it with the handles. You may need to do this back and forth in order to remove chips from the tube end. Please continue placing the oil on the end of the tube at all times. 5. Remove the tube from the threading tool and clean the oil and chip leftovers. 6. The tube is ready for use. Why are cone and thread connections used in high-pressure lines? Compression sleeve methods are not appropriate for sealing at high-pressure levels. Tubing is cold-drawn instead of annealed for strength. The main features of high-pressure needle valves are: the connection type is high-pressure CNT and is available in 3 sizes. Maximum allowed working pressure is up to 60,000. Hardened stem tip for longer life cycle, needle thrust bearing to ensure smooth operation, internal stem lifting stop that prevents stem blowout. Let's review our added values when compared to other manufacturers. The market is full of the same valve design and performance. Our high-pressure needle valves are designed to provide a long life cycle of more than 5 times higher than most competitors. The advantages are less maintenance, better safety, and higher reliability. As you can see in the table, our valves are over 20,000 cycles, while the other manufacturers are significantly lower. When comparing the CV value, you can see in the graph that our CV is 2 times higher than the competitive needle valve. Some of our added values include active stem seal, self-adjusting packing that requires minimum preloading, high performance of long-term sealing and eliminating lower life cycle and downtime costs. In addition, the ergonomic heptagonal shape of the handle, locked with 2 screws, enables easier operation. The advantage for this is free rotation reduction and smoother, easier handle operation, such as required in test benches.